Hello and welcome back to the video lecture series on statistics for machine learning. So till now what we were looking through were the univariate properties, right? I mean the properties of a single variable, a single attribute in a data set, which we call a set of observations, right? And the measures that we have looked into are mean, median, mode, the measures of central tendency, then the measures of dispersion like standard deviation, variance, mean deviation, quartile deviation, and stuff like that, right? Now, all these are related to one single variable, which is also called a univariate measure. What about if you want to see the relation between two variables or two attributes in a data set? Say, for example, I have a data set which has the height and weight of a set of students, right? And we represent them as the variable x and the variable y. How do I see whether they are related together? So for that, there is another very important statistical measure which is known as the correlation, right? Correlation, as you can understand, the name itself kind of implies co means mutual and relation means relation, right? So how are the association? So how these two variables or any two attributes of a data set are mutually associated, right? And say, for example, if the value of x increases, the value of y also increases. What do we say? That there is a positive correlation. And if we see that if the value of x increases, the value of y decreases, that may also be happening. Then we say then there is a negative correlation. This is a positive correlation, right? So this is how we go about it, right? But the essence is we always try to see how the basically how the increase or decrease in values of one particular attribute leads to the increase or decrease of values of the other attribute, right? That is what we try to see in essence. Now, how do we measure correlation? So for that, there is a very standard statistical formula. There are different ways, there are different statistical formula, but based on the absolute value of the attribute, there is one important statistical formula called Pearson's correlation coefficient. Okay, so how do we measure the Pearson's correlation coefficient? We need to find that out. So before that, we need to understand, just like variance, what is the formula of variance? So when we say var of x, how do we find out the var of x? As we have already seen, xi minus x bar, okay, divide summation of that divided by n. So same thing, y var of y will be yi minus y bar summation divided by n, right? Now there is one more important concept, which is covariance or cov of x comma y. How do we measure the covariance between x and y? So for that, the formula is very simple. It is xi, sorry, this is a square, I'm sorry. This is a square, variance we have a square. So this is xi minus x bar into yi minus, sorry, yi minus y bar. Okay, so product of that, okay, and then we divide it by the n. Okay, so this is the measure of covariance between two variables x and. So how do we calculate that? Again, using the same way, right? So here I have to find out xi minus x bar, right? So first I have to calculate the x bar. What is x bar? We have to find out. What is y bar? We have to find out. Okay, and then xi minus x bar. We do a xi minus x bar square, okay, and then do a summation of that. Same way we have to do a yi minus yi minus y bar, okay, and yi minus y bar square, yi minus y bar square, And then we have one more column here which does a xi minus x bar multiplied by yi minus y bar. Okay, yi minus y bar. Now, how do I do it? Say, for example, I'm not going to do the average of this thing. Let's take a very simple average. Say I take x bar as 50. Okay, this is a very random number I'm taking. I can do the maths and I can find that out. No problem. So let's, for the time being, take as 50. So this is going to be 0. This is going to be 1. This is going to be 9. This is going to be minus 2. Okay, this is going to be 2. Okay, this is going to be 2 and this is going to be 5. Okay, this is going to be 5. So here again I have to do a 2 0 1, then 9 square is 81, 9 square is 81, then I have a 4, I have a 4 and I have a 25. Okay, so let me say that the total, what's the total coming as? So 82, 86, 90 plus 25, so 115. Okay, and same way I do the yi minus y bar square. So say y bar, let me assume it is say 44. Okay, again I'm taking a very random number. Some other value may come actually when I do the maths. Okay, then again I have to do the same thing. 40 minus 44 is minus 4. This is 0. This is going to be 16. This is going to be 1. Sorry, minus 3. Okay, minus 3. So like this, I have to do the other things and say this is coming as 180. I'm again taking a very random number. Okay, so I have got. So this is no. I don't have to do this. Sorry, I do the yi minus y bar square. Say that is coming as 180. Okay, 180. And say the same way when I do this xi minus x bar and yi minus y bar, say this is coming to something like say 90. Okay, 90. Now the covariance will be, the correlation will be covariance of xy. So that is 90 divided by root over of 115, right? So root over of 115, let me say that that's going to come to something, say how much, say I am just taking a very rough number, say I'm taking as 11. Okay, it's going to be much different. And the second one, root over of 180, I'm just assuming again randomly, I'm assuming 13. Okay, it's going to be definitely something different. Okay, so 13 and 1 by n. So this is going to be divided by n. Okay, so n means there are how many? 6. 6 this thing. So into 6. So I have a covariance value. This xi minus x bar and yi minus y bar. 1 by n. I have to calculate that also. So that is coming as 90. So the covariance is coming as 90. Okay, I'm just putting it here in the this thing. Then I have this variance and root over of the variance I take as 11 and root over of the variance of y I take as 13. I mean, it can be a completely different value. I'm not going into that. And the number of observations is 6. So this is coming to something, say 0.25. Okay, whatever. I mean, I don't know what is exactly, or maybe we can just do this maths check for the time being. So it is coming as 90 divided by, so divided by what? Divided by 11 divided by 13 divided by 6. So this is coming as 0.1. Okay, so this is coming as 0.1. So the correlation of this particular data set is coming as 0.1. Now, how do I know this is a good correlation or not? So if I have a diagram like this, and this is say the x coordinate and this is the y coordinate. So the variables x and y I have as the two different coordinates. Now, if I have the values being plotted and when I plot the values, I get something like this. So I can see a very simple linear trend, increase in value of y when the value of x increases. I can say there is a very good correlation out here. But when this one gets a little muffled, I don't get a pattern out here. So there is no straight line which I can draw about it. So in that case, the value of correlation will be definitely very low. Then I can say that the correlation between the association between these two attributes is very low. Okay. So now let's try to see the same thing in Python. Okay. If I just take the same way as I took x, right? And the x represented acidity, fixed acidity. Now say I do a y and I do a volatile acidity. Okay. So this is a fixed acidity x and I do a volatile acidity. Okay. So let me put y is equal to, or rather let me just copy paste that and make that as y. Okay. And let make these as volatile. Okay. So if I do this, I get y as here, and then I can see whether y is having values or not. I'm sorry. Okay. So I can see that the y values are coming. Now if I want to see whether there is a good amount of correlation, so basically there is a statistical value correlation. So I can do the np dot, if I do a numpy correlation, so I can do a np corr, this correlation coefficient. Okay, if I do this and then I put x comma y, what do I get here? I should get a value of the correlation. Okay, it's giving a the value like this. So basically the correlation value is minus 2.56. So negative correlation of 0.25. Okay, now this is how I calculate in Python a numpy function. Same thing if I want to do using matplotlib and the scatter diagram, then I can get some kind of a plot like this between x and y. So let's try to do that. Okay. So we can basically use the simple scatter, just like the dot box plot in pyplot, there is something called scatter. Okay, and scatter will accept the two parameters for x and y. There are more other parameters. I'm not going to go get into that, but I just do a scatter. And sorry, I have to do a scatter. So see here, the scatter plot is not showing any specific trend. In a case where x and y are the two variables, they have a good amount of correlation, positive correlation, it would have been having a straight line like this, and in case there is a negative correlation, then it would have been something like this. So if there is a positive correlation, the line would be like this. If there is a negative correlation, the line would be something like this. But here there is absolutely no correlation, so we can see just a blob of data, right? So if I try to look at some other things, like here, if you see again for that auto MPG data set, I can see that there are, for the different pairs of attributes, I can see the correlation being plotted in the form of a scatter plot. Like here, I can see some kind of a negative correlation. Here, between these two particular attributes, there is a positive correlation. So displacement and weight, there's a positive correlation. Like this, you can use either the scatter plot, or we can also use this numpy function correlation coefficient to get the value of the correlation coefficient. And as many of us probably know, the value of correlation coefficient lies between -1 to +1. -1 means extremely high negative correlation, +1 means extremely high positive correlation, 0 means zero correlation, that means there is no association between the two attributes. And if the value is somewhere more than 0.67, it means there is a good amount of correlation between the two attributes. Okay, so 0.67, this correlation coefficient value of 0.67, higher than that means a pretty good amount of association or correlation between the two attributes. Okay, so this is how we can use the Pearson, and this is Pearson's correlation coefficient. There are other correlation coefficients like there is one rank correlation coefficient, so we can use that also, right? But here the Pearson's correlation coefficient measures based on the absolute value of the attributes. Okay, so I hope you have understood the different measures of bivariate. This is how we can explore the data, and either the data from a univariate perspective, so one particular attribute, or the data from bivariate perspective, so basically relation between attributes. Okay, so this is how we can explore the data. So let's stay tuned, and we are going to come up with more videos on more such important concepts in statistics which are very commonly used in machine learning. So stay tuned. Thank you very much.